Hello everyone, we are going to discuss the solution of JEE Main that was held on 22nd January 2025 evening shift. We are going to discuss the speed solution of that paper. So we'll start with the section A. Okay, the first question was asked is a symmetric thin bioconvex lens is cut into 4 equal parts by two planes AB and CD. Okay. 26. Physics. Okay. So this is one lens that is cut into halves. One is along the axis AB and then second one is along CD. So the final lens will be like this, the 1/4 part of the lens. The power of the original lens is 4D, so lens power is 4D for the original one. What will be the power of this lens? So when I cut a lens along CD, the power gets halved. This is a half of the initial lens, so its power will be half of this 2D. So what happens when you cut again this lens along this axis? It will be like this. So then there will be no change in the power. So final power of this lens will be 2D only. Okay, next question will go 27. It is given that a small rigid spherical ball of mass m is dropped in a long vertical tube containing glycerin. Okay. So one mass m is dropped in glycerin. The velocity of the ball becomes constant, so that means it has reached the terminal velocity. Or that means the velocity has become constant. If the density of the glycerin is half of the density of the ball, let's say the density of the ball is rho, so then the density of the glycerin is becoming rho by 2. Then the viscous force acting on the ball will be, so the force acting downward, that is the weight, that is m into g, and the buoyancy force is also acting upward, fb, and they will be ultimately balanced by introducing a new force, that is the viscous force. So that means mg will be balanced by the viscous force plus the buoyancy force. So what is the buoyancy force? Buoyancy force here, if I put, then I will get the value of viscous force, that is mg minus the buoyancy force. So buoyancy force will become rho by 2 density of the medium into v into g. Then rho and v is becoming mg because rho is the density of the ball, so it is becoming mg by 2. That is our buoyancy force. So that means the viscous force is becoming mg minus mg by 2, that is mg by 2. And that is the answer. Option number 2 is the answer. Okay. Question number 28. It is given that maximum percentage error in the measurement of density of a wire. So mass of the wire is given. Mass is given as 0.6 plus minus 0.003 gram. Radius of the wire that is given, that is 0.5 plus minus 0.01 centimeter. This is in gram. And length of the wire that is given, that is 10 plus minus 0.05. So percentage error in the density. So density, you know, density D is m by volume. So what is the volume of this wire? If it is a cylindrical wire, if you consider, m by pi into r square into L, density. So see, the power of m is 1, power of radius is 2, power of L is 1. So final density error will be the addition of error of m, r and L. So delta m by m plus 2 into delta r by r plus delta L by L. If we just put those values, delta m is given 0.003 by m is 0.6 plus 2 into 0.01 by 0.5 plus delta L is 0.05 by 10 it is asked in percentage, you have to just multiply with 100. That is the answer in percentage. So you can calculate the value. That is going to be 100. If we calculate, it is becoming half, plus if we multiply 100, it is becoming 2 by 0.5, that is 4, plus 5 by 10, that is half. So answer is 5%. So the answer is option number 2. Okay. The next question, that is also a very easy question. It is about the LCR circuit. A series LCR circuit is connected to an alternating source of EMF E. The current amplitude at resonance frequency is I0. If the value of resistance becomes twice of its initial value, then the amplitude of the current resonance will be okay. So the LCR series circuit is something like this. This is inductor, this is capacitor, this is the resistance. So it is connected across one battery. So at the resonance, what happens? The voltage dropped in capacitor and the inductor becomes same, but they are in opposite phase. So intercurrent, we can tell that I is becoming E by R. That is the resonance current. So if R becomes twice, then it's simply 2R, that is I0 by 2. That is a very simple question. That is the answer, option number 2. Now they are asking the next question from electrostatics. It is a dipole related question. Short dipole placed at origin. Okay, I will first draw the diagram. One dipole is placed at origin here, O, and its axis is like this, along x axis. So let's say it's plus minus, its axis is like this. This is point A, that is at R distance from the dipole, and that is the axial point. And at B point is situated at the perpendicular bisector of the dipole, that is at 2R distance, this is R distance. So at A, the electric field is E0 and potential is V0. Okay, you have to find out the electric field and the potential at point B in terms of E0 and V0. Okay, so at the axial point, what is the value of E or electric field for any dipole? Some constant multiplied by 2 pi by R cube, and potential V0, that is going to be some constant multiplied by R square. We can find out by integrating this with respect to R. E dot dr, if we do, we will get the same thing, some constant multiplied by this. And at the perpendicular bisector, this is about point A, this 2. At perpendicular bisector, the value of electric field will be constant multiplied by P by R cube. But here R is 2R, at distance 2R, so it will be 2R the whole cube. It will become Kp by 8R cube. So we know the value of 2P by R cube. So Kp by R cube is going to be 2 Kp will do 16R cube. So we'll get E0 by 16, that is the value of electric field at point P. But in this point, it is at the same distance from the plus charge and the minus charge, so the potential will become 0. So in this axis, any points, perpendicular bisector axis, any point, the potential will become 0. So the answer is 3, 0 and E0 by 16. Okay, the next problem number 31, that is also asked from basic dimension analysis, and of course is a combination of static electricity and dimension analysis. So we'll start. The dimensional formula of capacitance in terms of M, L, T and C. Dimensional formula of capacitance in terms of mass, length, time and charge. Okay. So capacitance, you know, capacitance is Q by V. So that means the dimension of capacitance will be, of course, the dimension of Q, that is our basic dimension right now by the dimension of V. So if I multiply Q, numerator and the denominator, will get Q square by QV dimension. So dimension of QV is the dimension of work. So the dimension will become at the denominator ml square to the power minus 2. Dimension of the numerator, that is of course given as the basic dimension C. So C square. So it will become C square m to the power minus 1 L to the power minus 2 T square. That is matching with, I think, option 4 it is matching with. So the answer is option 4. Okay, next one we'll do problem number 32. An electron projected perpendicular to a uniform magnetic field B moves in a circle. If Bohr's quantization is applicable, then the radius of the electronic orbit first excited state. Okay. Let's do this. Let's say this is a uniform magnetic field B. So electron is projected means it is rotating. Okay, let's say at this direction is rotating, whatever it is. So the centripetal force, that is mv square by r, that will be balanced by the magnetic force or the electromagnetic force, that is qvb, and mvr is our angular momentum, that is nh by 2 pi, but it is told that it is in the fast excited state. Fast excited state means n value from 1 it has gone to n equal to 2. So we'll put n equal to 2 here. So mvr will be 2h by 2 pi. It is becoming h by pi, that is the value of mv into r. So from here we can substitute the value of v so that we get the value of r, right? R is asked, yes. So v we can directly put from here. V is basically qb by m. V will put here, qv r by m. So we'll just put here, that is qb r square h by pi. The value of r is going to be root over of h by pi qb. Q is basically electric charge, so pi e into q. That is the answer. Answer is with, I think 4 is matching, so 4 is the answer. Answer 4. So basically you are able to see that a very easy question they are asking only, not very tough question. So if you have good practice, then you will be able to solve it very easily. So the next question will go, that is 33. For a diatomic gas, if gamma 1 is the ratio of Cp and Cv for rigid molecules, so for rigid molecules, that means in a diatomic gas, 2 molecules, this degree of freedom will not consider. Other vibrational degrees of freedom will not consider. Only it is rigid molecules. And gamma 2 for another diatomic molecule, but it is having the vibrational modes. So in the case of gamma 2, this mode will consider. They are vibrating. This mode will consider. Will add. So here, what is the degree of freedom? So okay, leave the degree of freedom part. It is not even asked. So degree of freedom in this case will be less than this. So F1 will be of course less than F2. Here another degree of freedom is getting added due to the vibrational mode. So what is gamma 1? Gamma 1 is 1 plus 2 by F1. Gamma 2 is 1 plus 2 by F2. But as F1 is less than F2, that means this entire part or this entire term will be higher than this one. So it is easily seen that gamma 1 is greater than gamma 2, and that is matching with the, I think, option number 4. Yes, option number 4 is the correct one. Okay, the next question we'll discuss. So I'll clear the board. That is also a very simple question. 34. So 34. A rectangular metallic loop is moving out of a uniform magnetic field region to a field-free region with a constant speed. when the loop is partially inside the magnetic field, the plot of magnitude of induced EMF with time is given by, they have asked in a graphical question. Okay. So let's say there is some magnetic field region. This is a magnetic field region. One rectangular loop that is moving out from the magnetic field. So inside there is magnetic field, of course there, constant magnetic field is moving out with constant velocity. Now let's say the dimension of this magnetic loop or the rectangular magnetic loop is A, here is B. This dimension is A, this is B. So as it is moving out, it is changing the magnetic flux, but the magnetic flux is reducing. If x is the length that is inside the magnetic field, then at any point of time, what is the area that is inside the magnetic field? X into B. What is the magnetic flux? B dot A, of course, but here it is cos 0, so we'll just put B into A is Bx into B. So d phi dt, you know, that is going to be, B is constant, small b also is constant, that is this length is becoming constant. So only variable is x because x is continuously reducing, so it is multiplied with dx dt, and that is also told that it is constant because dx dt, the rate of changing of x is constant, so it is v. So you are able to see that the d phi dt, that is the induced EMF, of course minus will be there, the induced EMF is a constant term, B into V. So it will ultimately become, the graph will become like this. If I draw, the graph will be like this, constant. So that is the answer. Answer is 4. Okay, it's time. The next question they have asked from the modern physics, photoelectric effect. A light source of wavelength lambda illuminates a metal surface and electrons are ejected with maximum kinetic energy of 2 electron volt. If the same surface is illuminated by light source of wavelength lambda by 2, then the maximum kinetic energy of the ejected electrons will be, and the work function is given of the metal, that is 1 electron volt. So okay, let's say this is a metal surface. The metal surface, it is getting illuminated by this lambda wavelength of light. So what is the energy that photons are carrying? hc by lambda. And the work function of this metal is phi naught. So the excess energy that is available, that is minus phi naught, that is going to be converted to the kinetic energy of the electrons. So we'll just write Ke directly. So hc by lambda, initial case, so hc by lambda directly will write, and work function is given as 1 electron volt equal to Ke max, that is 2 electron volt. So hc by lambda value you got, that is 3. Right now the same surface is getting illuminated by lambda by 2 wavelength. So the energy that is falling on the surface, that is lambda by 2. Excess energy is going to be minus phi naught, that is going to be the kinetic energy max for the electrons. So that is the maximum energy that is available to the electrons to get out from the surface. It is becoming 2 hc by lambda minus phi naught is given as 1, that is going to be Ke max. So hc by lambda value we already got from the first equation, that is 3. So 2 into 3 minus 1, that is 5 electron volt. That is the answer. 5 electron volt is the answer. Okay, option number 3, that is the answer. The next question, question number 36, is assertion reasoning type, and it is told that a simple pendulum is taken to a planet of mass and radius 4 times and 2 times respectively than the Earth. The time period of the pendulum remains same on the Earth and the planet. That is true because the time period, that is 2 pi root L by G. So when mass is becoming 4 times and the radius becomes 2 times, what is the change in the gravitational field? G is Gm by r square. So m is becoming 4 times, so 4m. At the same time, the radius is also becoming 2 times, so it is ultimately becoming the same. So that is the initial one. So for G dash is equal to G. So the time period is going to be same. T dash equal to T. And the reasoning is the mass of the pendulum remains unchanged at Earth and the other planet in the light of the ocean. Okay, so it has nothing to do with mass because the time period depends upon G only. So it doesn't matter with the mass. So mass is, that's true, but it is not the correct explanation of the assertion. So the answer is, I think it is given both A and B. Okay, A. Answer is 1. The next question is also very simple question. It is, see, NTA is asking very simple question only and just needs practice. Okay. The torque due to force about the origin acting on a particle whose position vector is this. So okay, F is given, that is 2I plus J plus 2K. R is given, that is the point of application. Coordinate, that is okay. So the torque is basically R cross F, the moment of the force, that is R cross F. Then I directly do it. So I, J, K, R will first write 1, 1, 1, 2, 1, 2, 2, 1, 2. So torque is becoming I multiplied 1, J, 2 minus 2, that is 0, J, 1 minus 2, that is minus 1, K. So I minus K, that is the answer, that is the torque. That is the option number 3. Question number 38. They have asked in the topic of logic gate. From the topic of logic gate, they have asked one question. Okay, so that is the input signal A and B is given. You can see the screen for the question reference. I'm just reading and solving. This is a quick solution, so I'm not explaining much. Okay, that is directly going, and then it is coming via NOT gate. Okay, it is very complicated to draw this. Okay, maybe the same thing is repeated. Okay, so I'll just from here we have another. It is going to, okay, now output Y. Okay, A is going directly. This is output B, will be changed to B bar. So here the output after this gate will be A B bar is the AND gate. So A B bar is the output from the first, you can tell, circuit. So here also same thing, B bar is coming here, A is coming here, so the final output from here is going to be A into B bar. So what will be this gate in order to get the output of, the first one is A is 0, B is 0, output, final output I should get, that is 1. Second one is 0, 1, 0. We can only check these two and we can find out that is what is going to be the gate. So here AB is entering, AB bar is entering. How to get 0, 0, 1? So if I give 0, it is not, how to make it 1? If it is like this, if from here, if it's changed to like this, then only it will become 1. Because 0, 0, then 0 bar is 1, 0. So ultimately 1, 0, 1, 0. 0 will put here, 0 bar is 1, 1 plus 1, then the third one is, okay, third one also we can check, that is 1, 0, 0, 1, 0, 0. So it is coming or not in this, this coming 1 bar is 0 plus 0, that is 0 of course, and the last one is 1, 1, so we'll put 1 bar, that is 0 of course, plus 1, so 0 plus 1 will become 1. Truth table itself is not right, so they have given bonus for everybody, but the actual truth table will be what is wrong in the question, that is it will be 0 0 1, 0 1 also will be 1, 1 0 will become 0, and 1 1 will become 1. So that will be the truth table. The actual truth table for the answer that is given is NOR gate. In the question, the truth table that is given, that is wrong. Okay. Okay, then we'll just clear the board and we'll proceed to the next question. Kind of simple question only NT asks. Okay, F force is given as 2I plus Bj plus K, and one particle that undergoes a displacement is also given, that is I minus 2J minus K. For what value of B, the work done on the particle is 0. So the work done on the particle is F dot S. What is F dot S? 2 minus B into minus 2 is 2B minus 1. That will become 0. The value of 2B is 1, B's value is half. So half is answer. The next question that is asked, in Young's double slit experiment, the fringes produced by red light are closer as compared to the produced by blue light. So the fringe width, so question number 40, the fringe width, that is d lambda by d, sorry, d lambda by small d, sorry, I'm so sorry. So for the red light, the value of lambda is the highest among the visible range. So the fringes will be at far away from each other than the blue light. For the blue light case, it will be, they will be closer. So it is given wrong. So assertion is wrong. The fringe width, yes. So assertion itself is wrong. So that means the option number 2. The next question, that is also very easy question only. Okay, we will not remove anything or not erase anything from the board. It is very easy to solve. Question number 41. A ball of mass 100 gram is projected with velocity 20 meter per second at 60 degree with the horizontal. The decrease in kinetic energy of the ball during the motion from the point of projection to the highest point. The ball of mass, that is 100 gram, that is 0.1 kg. Velocity is given 20 meter per second, projected with velocity 20 meter per second at an angle 60 degree. Projection, what is the kinetic energy? Half of mv square. M is 0.1, v square is 400, so it is becoming 20 joule. 200 into point of the 20 joule. At the highest point, the entire velocity will be the horizontal velocity, horizontal component of the velocity. So horizontal component of the velocity is 20 cos 60. That is of course 10 meter per second. So at the highest point, the value of the kinetic energy will be half of 0.1 into v square, that is 100. So 50 into 0.1, that is 5 joule. So the change or the decrease in the kinetic energy is from 20 to 5, that is decrease is 15 joule. That is answer. Answer is 2. Next question is from the optics chapter, 42. Question number, a transparent film of refractive index 2 is coated on a glass slab of refractive index 1.45. So 1.45 refractive index, it is coated with the coat of refractive index 2. What will be the minimum thickness? The thickness you have to find out of this coat for the maximum transmission of green light of wavelength 550 Newton meter. Assume it is nearly perpendicular. So if we assume nearly perpendicular, that means, so from the interface, if it is getting reflected, it's coming like this, reflected like this. So what is the path, optical path in this medium of refractive index 2 or in the coat? The normal path will be, of course, they're coming here and again it is going back. So total path will be 2t. but that path is traveled in the medium of refractive index 2. So the optical path will be 2, or the path difference will be 2, and that should be equal to the n into lambda. N is of course 1. So we'll put for the minimum value of t, n will be equal to 1. So the value of t will be lambda by 4. Lambda is given 550 Newton meter by 4. So that is 4115433047.5 Newton meter. The answer is option number 3. Option number 3 is the answer. The next question they have asked, okay, this is a very simple question from fluid mechanics. Tube of length L shown in the figure, the radius of the cross section at point 1 is 2 cm and point 2 is 1 cm respectively. The velocity of water entering point 1 is 2, water leaving the point 2. So they have given some kind of arrangement like this. So here the 2 cm, that is the radius, here 1 cm, and here the velocity is 2 meter per second. Here you have to find out what is the velocity. That is the question actually. So it is just a simple equation of continuity you can apply and you can find out what is the final velocity. That is question number 43 of course. So the volume flow rate will be constant. So volume flow rate is area of cross section, or the cross sectional area into the velocity. So A1 V1 will be equal to A2 V2 basically, or A1, that is of course 4 times the final A2, because here the radius is 2, here the radius is 1, so it is of course 4 cm square into V is already given 2, A is 1, V you have to find out, V is equal 8 meter per second. That is the answer. That is the option number 4. Question number 44, that is a very basic question from thermodynamics. So we'll discuss. Given are the statements from given are the statements for certain thermodynamic variables. A, internal energy, volume and mass are extensive variable, and let me tell you what the extensive variable means. That will depend upon the mass. The property that depends upon the mass, that is called extensive property, and the properties which do not depend upon the mass, that is intensive property. So internal energy, volume and mass, they are extensive variable. Okay, that is true because they depend upon the mass. Okay, internal energy depends upon the mass, but the specific internal energy, that doesn't depend upon the mass. So it is a true. A is true. Pressure, temperature and density are intensive variable. Okay, they all are intensive variable because they don't depend upon the mass. So A and B, they are true. Volume, temperature and density are intensive variable. Okay, the density is intensive variable, that is true, but volume is not intensive variable, it depends upon the mass. So it is not true, the C. And D of course is given that mass, internal energy are extensive variable. No, temperature is not extensive variable. So A and B are true. So option number 3 is the correct one. Okay, the next question 44, 45. The last question from section A. A body of mass 100 gram is moving in circular path of radius 2 meter on vertical plane as shown in the figure. The velocity of the body at point A is 10 meter per second. The ratio of the kinetic energies at point B and C will be. Okay, let us draw the diagram. Here the velocity at the bottommost point 10 meter per second. The point B is having the vertical angle with the vertical axis of course 30 degree, and the C point is having the angle with OB, that is 90 degree. The kinetic energy, okay, let us find out what is the kinetic energy at B. Without doing anything, you know what is the vertical distance of point B from point A. Vertical distance, that is R. R is given 2 meter. Vertical distance is this one. So this is basically entire thing is 2. This is 2 cos 30. The vertical distance between A and B is 2 minus 2 cos 30. H. So velocity at B will be, or velocity square at B will be, initial velocity square minus 2 into g into h. H is 2 minus 2 cos 30. So g will take as 10 only, so 20 will take 2 common, so into 2, 1 minus cos 30, that is root 3 by 2. Okay, we should not have taken the 2 common, it would be cancelled out anyway. 2 minus root 3. So 100 minus 40, that is 60, plus 20 of root 3, that is the velocity square. So its unit will be meter per second square. And at C, the vertical distance from A is going to be this one, entire thing. So if I divide it in two angles, we will ultimately get this angle to be 60, this angle to be 30. So it is how much distance? This is R, this is R, this is R sine 30. So that means R sine 30 means R sine 30, we can write R by 2, R is 2, so it is 1 meter, 1 meter, this entire thing is 2 meter. So vertical distance of C point from the bottommost point, that is 3 meter. So what will the velocity square? V square minus 2 into 10 into h, h is 3, so 2g into 3. So it is becoming 100 minus 3 to 60, so 40. Their kinetic energies ratio of B and C. B and C will be 60 plus 20 root 3, because it's just the ratio of their velocity square, by the way. That is the kinetic energy ratio. So they are going to be, we have to just simplify it. So 20, 23, 2. So 3 plus root 3 by 2, that is answer. That is the answer number is option number 3. Option number 3 is the answer. Okay. Okay, so we are done with the section A. Section B we will discuss. Okay, now we'll start with the section B. The question number 46. It is said that a proton is moving undeflected in a region of crossed electric and magnetic field at a constant speed of 200 to the power 5 meter per second. When the electric field is switched off, the proton moves along a circular path of radius 2 cm. The magnitude of electric field is x into 10 to the power 4 Newton per Coulomb. The value of x. Okay. Let's say this is the magnetic field. One positive charge is moving in this direction with velocity v. The magnetic force due to this velocity is v cross b, q into v cross b, and v cross b is in this direction. So if there is electric field in this direction, there will be electrostatic force QE amount will be acting in this direction, and magnetic force will be q into v cross b. So by the way, this is becoming qvb. So it's undeflected means the magnetic force will be equal to the electrostatic force. Then the value of v will be equal to E by B, and we do not know the value of B. We have to find out the value of E. From the B we will find out E, and it is said that from circular path of radius 2 cm it is moving when the electric field is switched off. So that means the radius, the proton will circulate when the electric field is switched off, that is R, that is mv by bq, you know that. The value of the magnetic field is mv by q into R. We just put that here. E mv by q into R. So the value of the electric field to find out, that is m into v square by q into R. So we'll just put those values. 1.6 into 10 to the power minus 27 into v square. V is given as 2 into 10 to the power 5. 2 into 10 to the power 5 square by Q, we know 1.6 into 10 to the power minus 19 coulomb. R is given 2 centimeter means 0.02 meter. It's just a simplification after this. So it is 1.6 will cancel. It is 10 to the power minus 8 into 10 to the power 10 into 4 by 2 into 10 to the power minus 2. So it is becoming 10 to the power 10 200. So 2 will cancel. 12 minus 2 into 10 to the power 4 Newton per coulomb. You need to find out the value of x. The value of x is 2. That is our answer. The next question, question number 47. Two long parallel wires x and y separated by a distance 6 cm carrying current 5 ampere and 4 ampere respectively. We'll just draw the diagram first. That is x, that is y. It is carrying 5 ampere current in upward direction, and this is carrying 4 ampere current in the downward direction. Their separation is 6 cm, it is given. You have to find out the magnitude of the resultant magnetic field at a point P, a distance 4 cm from the wire Y. So let's say there is some point from the wire Y that is having the 4 cm distance from the wire Y. To find out the magnetic field in this region, value of the magnetic field. Okay, and okay, it is already given. The value of magnetic field is x into 10 to the power 5 Tesla. So what is the value of x? You have to find out. Okay, see, due to this wire, it is a infinite wire in both the directions. So due to this wire, the x wire, the magnetic field at this point will be downward direction. So B, due to x, it is mu naught by 4 pi 2I by R. R means the distance of this point from the wire. So 10 centimeter. 10 centimeter means 0.1 meter. We need to write the SI unit. B due to y, that is going to be, it is downward, that means the upward direction. If we do the cross, we'll get the magnetic field to be at upward direction. So if we consider this as a plus, this will be minus, of course. So it is going to be mu naught by 4 pi, put minus 2 into I by R is the distance of the point from the wire, that is 4 centimeter means 0.04 meter. So the net is this plus this, so ultimately this minus this. So mu naught by 4 pi 2I by 0.1 minus 2I by 0.04. Value of I for this wire is I1, I2, so it is 5 ampere. We'll just put the values. 0.1 minus 2 into 4 by 0.04. So 10, it is becoming 100, minus 800 by 4, that is 200, 10 to the power minus 7. So the value is becoming ultimately minus 1. So minus 1 plus 1. So the magnitude is basically 1 into 10 to the power 5 Tesla. So the value of x is 1. That is the answer. Okay, next question is question number 48. A parallel plate capacitor of area A equal to 16 centimeter square, and the separation between the plates 10 centimeter is charged by DC current. So we'll just draw the capacitor like this. We'll just draw. Okay, area is given as 16 centimeter square, and the separation between them is 10 centimeter. Is charged by DC current. Consider hypothetical plane surface area 3.2 centimeter square. So in between I have to consider a small surface area, that is 3.2 semi square. Inside the capacitor and parallel to the place. Okay, at an instant the current through the circuit is 6 ampere. So net current flowing is 6 ampere. At the same instant the displacement current through A0 is how much in milliampere? You have to find out. So it is very simple to find out what is the value of the current density through these plates. Current density is becoming 6 ampere by 16 centimeter square. So it is becoming ampere per centimeter square. You can consider the same current density will be applicable for any cross section area that is placed between this. So the current density for this small cross sectional area will also be J. So the current through this small cross sectional area will be J into A naught. J value we already know, 16. And the area of this we got. So ultimately this is the ampere. So 6 into 32 by 10, 16, 16 to 12, so 1.2 ampere, 1200 milliampere. So answer is 1200. Okay, so the next question, question number 49. A tube of length 1 meter is filled completely with an ideal fluid of mass 2m and closed at both ends. The tube is rotated uniformly in horizontal plane about one of its ends. So we just draw the diagram. Maybe this is a tube. Tube is rotated in horizontal plane with respect to one extreme end, and if force exerted by the liquid at the other end is F. So if it is rotated, let's say the density of the liquid is rho. If it is rotated like this, so this face will experience some force in this direction, and that force amount is F. We have to find out, and the mass of this liquid inside is given as 2 into m. So let's say the cross sectional area of the tube is A and this length is L. That means rho into volume, volume is A into L, that is ultimately 2 into m, that is given. And angular velocity of the tube is given as omega equal to root over of F by alpha into m. So we have to find out what is the value of alpha. Okay. Length is given as 1 meter. Okay. See, this is a problem where we have to use our integration technique. So let's say at any point or any cross-sectional area, we'll just consider a small cross-sectional area that is at distance, let's say r from the point of rotation. So let's say this length is dr. So this volume, this differential volume will become A into dr, differential volume. So what is the differential mass? dm, small mass that is there inside this small differential volume is rho into that. So if I consider this as our control volume, then the amount of force exerted in this end will be dm into omega square into r. R is the distance from the point of rotation. So that is becoming our differential force, small force. So total force, I have to find out, we have to integrate dm omega square into r from 0 to capital L. Value of dm is rho A into dr. We'll just put rho A into dr omega square r, integration from 0 to L. Rho A omega square constant, we'll just omega square r dr from 0 to L. Integration of r dr is r square by 2. If we put the limits, it will be ultimately rho A omega square L square by 2, that is F. And we know what is the value of rho A into L, so we can just separate this part. Rho A into L omega square L by 2. This is our 2m. We can directly put it from this. So 2m, if we put 2 will cancel out, so it will become m omega square into L. So that is our F. So F we got, that is m omega square into L. L is 1, so that means multiplied with 1. So value of omega is becoming root over of F by m. The coefficient of m, that is 1. So our answer is 1. That is the value of alpha. Done. Okay. The next question, it is a current electricity question. We'll just directly wipe out the board and then we'll proceed to the next question. The last question of our physics paper. Okay. Question number 50. I'll just draw the circuit to find out the net current flowing in the given circuit. Okay, total current flowing in the given circuit. 2 volt, 2 ohm, 4 ohm, okay, 3 ohm, 2, 4, then 2.5, there's a capacitor, 5, 6, it is directly connected, shorted, 8, 1, 4, okay, and this current is DC. Okay, so we have to find out the total current flowing in the circuit. See, as it is DC current or DC source, that means this capacitor part will not let any current to flow in this region. So you can see that this circuit, this part is cut off totally cut off this part, because no current will flow in this region. So our equivalent circuit will be reduced to this 2, there is 3 ohm, there is 4 ohm, and 6 ohm is like this 2. So see, 6 and 3, they are parallel connection, because this part is having no resistance. So we can redraw this part as this. So this is parallel connection, means what is the equivalent resistance? 6 into 3, R1 R2 by R2 plus R2, 6 plus 3. So 2 ohm is the equivalent resistance placed here. So we can directly substitute this with the 2 ohm resistance. Now see, this 2 ohm and 2 ohm, they are in series connection. So we can replace this with 4 ohm. Then again 4 ohm and 4 ohm are in parallel connection. So 4 ohm, 2 4 ohms when they are connected parallelly, the equivalent resistance will become 2 ohm. So ultimately, the equivalent resistance of the circuit is reduced to 2 ohm. And the current in the circuit is volt by resistance, or the potential difference by resistance, that is 1 ampere. So 1 is our answer. Yeah, thanks for watching. This is the speed solution of the January 22